study. Yes. And why do elements in the same group behave in similar ways? Okay, so well, this chapter will answer all of the questions. कि जो भी हमारे questions हमारे जो भी doubt है related to the elements periodic table, so we will answer. I will answer each and every question. Okay, so in this chapter we are going to study that. Okay, so this chapter basically it focuses on how scientists discovered a pattern, right? How he just discovered a pattern in chemical behavior, right? Chemical behavior of different elements, right? And he used those patterns to classify them. Okay, so आज जो हम देखते हैं modern periodic table में, so that was a very it was you can say it was a modern periodic table, right? उससे पहले भी काफी periodic table आए which was discarded, right? जब वो modern periodic table जो आज हम use करते हैं, that was the main periodic table which was successful. Before that, there were many periodic table, many scientists who gave the periodic table, but their periodic table anyhow it was discarded, right? Due to some reasons, due to some limitations, they were discarded. Okay, so in this chapter we will see that how the historical, what is the historical development, how the periodic table is just developed from the initial to the final. Means from the simplicity to the complexity. Okay, so we will discuss basically a genesis of periodic table first. Okay, so genesis of periodic table means the historical development of periodic table, how the periodic table just developed from the simple to the very complex. Okay, because at that time when the Dobriner come, when the Dobriner, he was a scientist in the 1800, right? 1800. I'm just talking about the 1800 century. So at that time, only 31 elements were known, right? उस time कितने elements known थे? Only 31 elements, right? But after that, Newlands come in the 1865. So this 31 is just multiplied to double, right? Means total 63, approx 63 elements were known at the time of Newland, right? In 1865. After that, many different elements discovered, right? And now, till now, there are 118 elements which were known, okay, which were placed in the periodic table. Okay, so when the Dobriner come, so yeah, when the Dobriner come, he just in 1800, so he just gave a triad. Okay, so Dobriner, he was the first one who just who just arranged the certain elements based on the similar properties, right? He just arranged certain elements. So he was the first one to give the triad. He was the first one who just initiated the study of periodic relationship, right? First one who initiated the study of periodic periodic relationship, right? Periodic relationship. He was the first one. Okay, so let's see what he just gave. What was the statement and उन्होंने क्या कहा था about the periodic table. So, right, so he just worked on the periodic table between 1800 to 1829. Okay, so in 1800, Dobriner he arranged certain elements. Okay, that was a major limitation. उन्होंने सिर्फ certain elements के बारे में बताया था. He just arranged only certain elements based on the properties which have the similar properties in groups of three. Okay, he just arranged the elements in a group of three in such a way that the atomic mass of the middle element was nearly same as the average atomic mass of the first and third elements. Okay, he just arranged three. Okay, उन्होंने क्या दिया था? Group of three elements. He just arranged in that order. In that order, see this chart. See this table. Okay, is it visible? See the table. First triad, second triad, and third triad. Okay, he just gave the three triads. Okay, and we know that what is triad? So triad means three. Okay, the group of three, which means triad. So first triad, second triad, and third triad. In the first triad, he just arranged elements like lithium, sodium, and potassium. Okay, lithium, sodium, and potassium. And he said that the atomic mass of sodium is equals to the average atomic mass of these two, first element and the third element. Means lithium and potassium का जो average atomic mass होगा, right, that is equals to the sodium. Okay, so he just said that. Now see, we know that atomic mass of lithium is 7, right? And the atomic mass of potassium is 39, right? When you take the average, like 7 plus 39 divided by 2, right? When you take the arithmetic mean, or you can say average, so you will get 23. And what is 23 is the atomic mass of sodium, right? So he just said that, right? Means the second case, second का जो atomic mass होगा, it is always equals to the arithmetic mean of the atomic mass of first and third element. Okay, and he just gave a group of triad. First triad was that. Second triad, similarly, calcium, strontium, and barium. Okay, calcium first, second element was strontium, third element was barium. Okay, he just put accordingly, and these elements have the similar properties. Okay, he just placed these elements based on its similar properties. Okay, similar properties. And he said that, see, the second triad, atomic mass of strontium is equals to the average atomic mass or arithmetic mean of atomic mass of calcium and barium. So calcium has 40, barium has 137 divided by 2, right? So you will get 88.5. Right, almost similar, not the exact. He said almost similar, like 88.5 आपको average mean मिल रहा है. So strontium has 88. Atomic mass of strontium is 88, which is approximate to this. Okay. Third triad, which is fluorine, bromine, iodine. Similarly, 35 plus 127 upon 2, you will get 81.5, which is approximate to 80. Okay, so he just said that the atomic mass of the second element, middle element, has nearly same, not the exact. Okay, he said that nearly same hoga as the average atomic mass of the first and third element. Clear? So Briner tried clear?
Yes, ma'am. Clear.
Yeah. Now let's see what are the limitations. What are the limitations of the Briner triad? Because you can see over here, he just gave the triad of only certain elements. Okay, because at that time, at the Dobrainer tribe time, 31 elements were known, right? But he was unable to explain the triad. He was unable to give the triad of all the 31 elements. Okay, ये उन्होंने सिर्फ ये 9 elements के triads दिए. Only 3 triads he just gave. Okay, so that's the major limitation. So the triads given by Dobriner were helpful in grouping some elements with similar characteristics together. Okay, but he couldn't arrange the elements known at that time into triads. Okay, he couldn't arrange all the elements known at that time. Okay, so that's the limitation of Dobriner. Clear?
Yes, ma'am.
Okay, so just write it down, the limitation and the characteristics. Done? Can I scroll down?
Yes, ma'am. Done.
Okay. So that was the limitation of Dobriner types. Now, after Dobriner, so Newland came. Okay, Newland, he just gave a law which is known as Newland's law of octave, and he was the first to correlate the chemical properties of the elements with the atomic masses. Right? Because Dobriner ने chemical properties से relate नहीं किया था atomic mass. Okay, he just gave the element and the atomic masses, right? But Newlands, he was the first one to correlate the chemical properties of the elements with the your atomic masses. Okay, and according to the law of octave and law of octaves, if the elements are arranged in the order of the increasing atomic weight, okay, if you arrange the elements in order of increasing atomic weight, then the eighth element, okay, when you are starting from the first element, then the eighth element and the first element has the similar properties. Okay, they are similar in properties. And they just arrange, see the table here. Sa, re, ga, ma, pa. Right? So accordingly, sa, re, ga, ma, pa, da. Right? Pa, da, ni. So Newlands, he called it as a law of octaves. Octaves means octa means it. Octa means eight, right? Octa word is used for eight. So there are eight elements. He just arranged the elements in eight, right? Series of eight. And he John Newlands, he proposed the law of octaves, right? And he just started like from hydrogen, lithium, beryllium. Helium was not, noble gases were not discovered at that time. Okay, noble gas उस time discovered नहीं हुए थे. So at that time, at the time of Newlands, your some 63 elements were discovered, right? At the time of Newton, 63 elements were discovered. So he just gave the uh, a series of elements, and he just said that the first element, right, like hydrogen, say if you are starting from hydrogen, first, second, third, fourth, fifth, sixth, seventh, right, and then eighth. This eighth, fluorine. So this first and eighth element, right, has the similar properties and they are arranged in a same group. Okay, so this hydrogen, fluorine, chlorine, cobalt, nickel, and bromine, they have similar properties according to Newland. Okay, and just like a similar relationship between that the relationship which exists for the musical notes. Okay, he just compared it as a musical notes like sa, re, ga, ma, pa, dha, ni. And then you will again start with the sa, right? So similarly, sa, all the sa, like this hydrogen, fluorine, chlorine, and these all have similar properties according to the new line. Okay, so he arranged according to first, he just arranged the elements according to the increasing order of atomic masses. And he said that every eighth element, like first, if you are starting from the first, so every eighth element has the similar properties to that of first. Okay, first and eighth element ka similar properties hoga. If you are starting with hydrogen, so it's hydrogen and fluorine has similar properties. Okay, अगर आप similarly अगर lithium से start करते हो, right? So 1, 2, 3, 4, and similar. When you are starting with lithium, so the eighth element was sodium, right? So sodium and lithium has similar properties according to the new line. So it is clear? Is it clear? Neha and Simra?
Yes, ma'am.
Yes.
Any doubt?
No,
Okay,
ma'am.
so he just compare it as a musical notes like sare gama pada ni. Okay, and again the sa come, so it repeat. यहाँ पे repetitions हो रही है. Okay, so every repetition has the similar properties. Like first and eighth element have the similar properties according to the new line. Now, what is the limitations? Okay, so what is the limitations? So the major limitation is that he just explained, and this classification of Newland was successful only up to the calcium. Okay, it was only successful up to the calcium because this classification it worked quite well for the lighter elements only. Okay, जिसके atomic masses light है, right? That it works only for that. Okay, till calcium. After that, every eighth element didn't possess the same properties. Okay, after calcium means the heavier elements. For the heavier elements, this Newland's law it failed, right? It just failed in case of heavier elements, and therefore it was discarded. Okay, due to these limitations, this Newland's law of octaves were discarded. Okay, first limitation was that. Second limitation was that when the noble gas elements, जब noble gas elements were further discovered, okay, at the later stage, when the noble gas were discovered, then when the noble gas were included in this table, it these table got disturbed. ओके ये टेबल पूरी तरह से डिस्टर्ब हो गया मींस जो न्यूलैंड ने कहा था कि एवरी एट्थ एलिमेंट दे हैव द सिमिलर प्रॉपर्टीज टू दैट ऑफ फर्स्ट तो वो अब एप्लीकेबल नहीं होगा when the noble gas elements were included like see noble gas we know that right helium your neon and argon krypton xenon right so these are the noble gas we know that now, when the noble gas further they discovered at the later stage, उस time noble gas जब न्यूलैंड ने ये law दिया था, तो at that time noble gas were not discovered at that time, okay? But further at the later stage, when the noble gas were discovered and when they are included in this table, so hydrogen after hydrogen we know that it is helium. Second atomic number is second. Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, then sodium and so on. Now see, this is the first, right? Second, third, fourth, fifth, sixth, seventh, eighth. Right? Eighth tak hai, we will see. So now see, this is the first, hydrogen is the first element, and when you're counting, so oxygen is the eighth element. So now see, according to the Newland, what he said, every eighth element, right, when you are starting from the first and eighth element has a similar properties. But when the noble gases are included, right, the hydrogen and oxygen has not a similar properties. Okay, hydrogen and oxygen का similar properties नहीं था. Means every eighth element has not a similar properties just like a first one. Okay, so that's the major limitations when the noble gas has been discovered and they are included in this table. Clear?
Yes, ma'am.
Any doubt?
No,
Okay.
ma'am.
Yeah, so that's a major limitation when the novel gets further discovered. Okay, so just write down. Then we will see after the Newland's law of phase, Mendeleev's periodic table.
Done.
Okay. Neha done?
Yes, ma'am.
Okay, so the next is your after the Newland's octaves law of octaves, the Mendeleev's he gave a periodic table. Okay, he just gave the periodic table, and it was a very successful periodic table at that time. Okay, so at Mendeleev's, because we know that Dobriner he just initiated the study of periodic relationship, right? But it was the Mendeleev, right, who was responsible for publishing his periodic table, periodic law for the first time, right? जो written record था जब publish हुआ था first time, it was the Mendeleev's periodic table which was published, right, for the first time. Okay, so just Dobrine, just remember that Dobriner, he initiated the study of periodic relationship, but Mendeleev's, he was responsible for publishing the periodic law for the first time. Okay, and at that time, this periodic table was very successful. Okay, was very successful. Now see, according to Mendeleev's periodic table, what he gave, so see this was a periodic table which was given by Mendeleev. Okay, so this periodic table was given by Mendeleev, and he said that according to him, the physical and chemical properties of all the elements in the periodic table, they are periodic functions of their atomic mass, right? उसने भी Mendeleev's ने भी he just relate the physical and chemical properties with atomic mass. Now you can see over here till now like Dobriner, your Newland, and now Mendeleev's. They all just talk about the atomic mass, right? They said that the properties are periodic function of their atomic mass, right? But after this Mendeleev, the modern periodic table is based on the atomic number. Okay. After this Mendeleev, the scientist named Moseley, he just said that, he suggested that the atomic number instead of atomic weight. Because abhi tak jo bhi scientists aa rahe the, they just talked about they just arranged the periodic table according to their atomic weight, right? But when the Moseley, after this modern Mendeleev periodic table, when Moseley come, he said that instead of atomic weight, we should take atomic number, right? And according to the atomic number, based on the increasing order of atomic number, the elements should be arranged in the periodic table. Okay, and that was the modern periodic table. जो बहुत ही सक्सेसफुल अभी भी जो हम यूज करते हैं दैट्स अ मॉडर्न periodic table which was given by Moseley. Okay, so we will see further, but first let's see the Mendeleev's periodic table. So Mendeleev's he gave the periodic table, and based on and he said that physical and chemical properties of all the elements, they are the periodic function of their atomic masses. Are periodic function of their atomic weight. Means it depends on their atomic weight. Atomic weight. Okay. And he arranged the known. This time, I think 63 elements were known, and he just arranged those elements in order of their increasing atomic masses. Okay. And he said that the elements are arranged with similar properties. The elements which have the similar properties are just kept in a vertical columns, same vertical columns. Okay, so you can see over here, this is the vertical columns, and he said those vertical columns as groups, right? Groups को क्या कहते हैं? That's the vertical columns. Vertical columns is known as groups, and he said that the elements which have similar properties, they are kept in same groups, same vertical columns. Okay, and he just said that the horizontal rows horizontal rows are known as periods. right? Now, what are periods and what is groups? So, group is a vertical columns, okay, and horizontal rows are known as periods. These are groups like 0, 1, 2, and so on, and these are known as periods, which are horizontal rows. Okay.
Yes,
Yeah.
ma'am.
Okay, so he arranged the known elements in order of increasing atomic masses. Okay, and he said that there is a group, and group में कौन से elements होंगे? Those elements which have the same properties, similar properties, not the same, similar properties. They will occupy the same vertical column, right? And vertical column, we know that it is a group. And he left some spaces. You can see the spaces after this, right? There are some spaces, right? So he left some spaces where he thinks it is necessary, like कुछ भी physical properties लिखने के लिए या कुछ भी something which could be discovered further, right? Later जो discover हो सके तो उसके लिए उन्होंने some spaces छोड़ दिया, right? So you can see over here, these are some spaces which were left by the Mendeleevs in their periodic table. Okay, and this table was divided into, you can see this table, this periodic table, it was divided into your 9 groups. Yeah, you can see how many groups are there? 9 groups. See, 0, 1, 2, 3, 4, 5, 6, 7, and 8. These three. 8 is something different, right? 8 क्या है यहाँ पे सबसे different है थोड़ा सा. Why? Because they have, 8th group have 9 elements. 8th group has 9 elements which are arranged in a triad, right? So these whole group, this all group is known as 8, right? 8th group thoda different hai. Why? Because it has 9 elements and they are arranged just like a triad. Triad ki tarah they are arranged. Okay, so groups are 9, 0, 1, 2, 3, 4, and so on. You can see over here. And the periods, right, means your horizontal rows. How many horizontal rows are there? So basically there are, you can see 7 periods, right? 1, 2, 3, 4, 5, 6, and 7, right? So you can see there are 7 periods and 9 groups according to Mendeleev's periodic table. Okay, so just remember, according to Mendeleev's periodic table, how many groups are there? So 9 groups, okay, and 7 periods are. And groups are vertical columns and periods are horizontal rows, right? Okay. And yeah, see, the groups are always, by Mendeleev, he just gave the group name as Roman numerals. He just denote the group names as a Roman numerals. 1, 2, 3, and so on, just like this. But periods name, he just write as a number, like this: 1, 2, 3, 4, 5, 6, and 7. 7 periods are there. Okay, so periods को उन्होंने normal numbers की तरह लिखा, just like a digit, 1, 2, 3, and so on. And groups को he just denoted by a Roman numerals. Okay, yeah. So according to him, the physical and chemical properties of the elements are periodic functions of their atomic masses. Okay, Mendeleev, he arranged the elements which were known at that time in order of increasing atomic masses, right? And this arrangement was called the periodic table. Here, and the elements with similar characteristics were present in vertical column, which were known as groups. Okay, and the horizontal rows were known as periods. And there were 9 groups in the Mendeleev periodic table, which was indicated by a Roman numerals 1, 2, 3, 4, 5, 6, 7, 8, and 0. Okay, and groups. Group 8 is a little bit different from the others, right? Because it consists 9 elements. Total 9 elements are there in group 8, which were arranged in 3 triads. Okay, you can see over here they are arranged in 3 triads: iron, this, okay, osmium, ruthenium, cobalt, and so on. Okay, and 0 group consists of noble gases. You can see over here. So this 0 group, right? These are consist of your noble gases. Now here's a question: why these noble gases were put in the 0 group? Is there any specific reason Mendeleev just put it in the this noble gases in the 0 group? उन्होंने फर्स्ट ग्रुप में क्यों नहीं पुट किया, सेकेंड में क्यों नहीं पुट किया, व्हाई जस्ट पुट इट इन द जीरो ग्रुप, उसके लिए अलग एक ग्रुप बनाया, right? So see, the zero group, it consists of elements which is noble gas, right? Because noble gas has zero valency, right? It has a zero valency. That's why he just put it in the zero group. Okay, so due to the zero valency, is उन्होंने एक और group बनाया which was for the inert gases, noble gases. Okay, so that's why he just put it in the zero group, all the noble gases. Yeah. We know that periods are seven according to the Mendeleev's, which is numbers 1 to 7. So clear?
Yes, ma'am.
Mendeleev's periodic table समझ आया? Is there any doubt?
No, ma'am. All clear.
Now see what are the importance or what are the merits? Okay, importance and merits of Mendeleev's periodic table. So basically, Mendeleev's he just simplified. Okay, he just simplified and systemized the study of elements. Okay, and their compounds. Mendeleev's he just सिंप्लीफाई उन्होंने सिंप्लीफाई कर दिया राइट बिकॉज before Mendeleev's Newlands were there, right? Newlands and the Brinus, he just don't give the simplified form, right? Simplified form of the periodic table. Okay, उन्होंने कुछ elements की बात की थी, कुछ elements को छोड़ दिया था, right? But this time Mendeleev's this made the he just made the study of elements quite systematic, right? In the sense that if the properties of one element in a particular group are known, then those of others can be predicted. अगर एक प्रॉपर्टी अगर नोन है किसी भी ग्रुप में, बिकॉज दे ही जस्ट पुट द एलिमेंट्स elements in a similar elements, similar properties of elements in a similar in a same group, means अगर group एक ग्रुप में अगर जितने भी एलिमेंट्स है दे हैव द सिमिलर प्रॉपर्टीज. ओके, तो अगर एक प्रॉपर्टी एक का प्रॉपर्टी पता है तो यू कैन जस्ट प्रिडिक्ट द अदर्स प्रॉपर्टी आल्सो which was in the same group. Okay, same group में अगर कोई भी elements हैं, so you can just predict the properties accordingly, because according to Mendeleev's the elements were just kept or placed in the periodic table in the same group when the same group which have similar properties. Okay, like you just put the noble gas in the zero group, right? Zero group, all the noble gases are there, so they have the similar properties. Okay, so zero group elements which is a noble gas has the similar properties. अगर आपको helium की property पता है, so you can just predict the neon property, argon property, krypton, xenon, and so on. Okay, so this was the main, you can say, merit of Mendeleev's periodic table. Okay, so he just simplified the study of elements. Okay, he just made the study of elements quite systematic. Okay, in the sense of properties of elements, of you can say. And yeah, this Mendeleev's periodic table, he it also helped in the discovery of these elements at a later stage. Okay, new elements को जो further discovery हुई, तो this Mendeleev's periodic table also helped in that to a great extent, because this Mendeleev's periodic table he just put the elements or place the elements accordingly, right, on the basis of chemical and physical properties. Okay, so that's what he just, you can write, this helped the scientist to a great extent in the discovery of various other elements. In the discovery at a later stage. Yeah. And yeah, Mendeleev corrected the atomic masses of certain elements with the help of their expected position and properties. Okay, he just predicted that some elements have different physical properties, and he just predicted, because at that time that element were unknown. Okay, this time known nahi tha, right? That element was not discovered. He just predicted, and when the element were discovered later, it comes out that what he predicted was right, was true, right? Means the properties of that element which was predicted by Mendeleev was found experimentally, and when it found experimentally, it was quite similar to that properties which was predicted by Mendeleev. Okay, so let's see, we will see what are those. First, write down this. First, write down all this. Then we will discuss what are those elements जो उन्होंने predict किया था and what are the predictions which was made by Mendeleev. And you can see over here the yellow color dot, okay, yellow color dot, blue color dot, and red color dot in this periodic table. So these shows, yellow color shows the lanthanoid series. Okay, means your F block elements, lanthanoid series को ये denote कर रहा है. And your blue color shows actinoid series. Okay, again it's a F block elements. Okay, so it has a separate उन्होंने कुछ ऐसा नहीं दिया था, उसको इसी में इंक्लूड कर दिया था Mendeleev's ने. And the red color, it shows the known to ancients, means ancient times से ये elements known थे. Okay, so that's the which is denoted here by red dot, like your calcium, copper, sulfur, silver, okay, your gold, mercury, etc. These are the ancient elements, okay, which were known to ancients. And yeah, this these checks lines like this shows the Dobryna's triads. Like you can see here lithium, sodium, potassium, calcium, strontium here. So all these shows that these elements were present in the Dobryna's triads. Okay, these were known at that time. And this solid color, this line is blue line. It shows the Mendeleevs. Okay, these are the elements which were known at the time of Mendeleev.
Done.
Done?
Yes, ma'am. Done.
Huh? Sure. So the primary aim of this Mendeleev's periodic table was that he just his primary aim of was that he just arranged the elements of similar properties in the same group. Okay, that was the primary aim of the Mendeleevs. Okay, ये क्या कर रहे थे? He just arranged the elements based on its similar properties in the same group. Okay, and he just said that the same group elements have the similar properties. Okay, so you can see over here the noble gas elements which have the similar properties, they are put in group 0. This hydrogen, lithium, and these alkali metals, these are put or placed in the group 1. Okay, similarly, halogens, these are placed in the group 7. Okay, so his primary aim was to put the place the elements of the similar properties in the same group. Okay, but when he just proposed this periodic table, he find that some of the elements were still undiscovered. Okay, some elements were still undiscovered, and he left several gaps in the table. Okay, he just left several gaps in the table. For example, you can see, yeah. For example, the gallium and germanium are not discovered at that time. Okay, so gallium and germanium were unknown at that time. At that time, when the Mendeleev's periodic table was published. Okay, so he just left the gap under aluminium and your silicon, and he just called it as Eka aluminium. Okay, he just called it as a Eka aluminium and Eka silicon. Okay, what I said, I'm just repeating. I said that at that time when the Mendeleev's periodic table published, okay, so this gallium and germanium, these two elements were not discovered, were unknown at that time. Okay, so he just put the space. He just left the space. Okay, left the gap under aluminium and a gap under the your germanium, not gallium and germanium के अंदर वो उन्होंने gap रख दिया, and he just called it as a Eka aluminium and Eka silicon. Okay, so under the gallium and in the place of gallium and germanium, he just placed a gap. Okay, why? To when they were discovered, so they were placed at they were put at that place. Okay, so he just called gallium as a Eka aluminium and germanium as a Eka silicon. He just predicted. Okay, there is no particular proof, and he just predicted that why Eka aluminium. He think that this aluminium, it just behaves like this Eka aluminium, it just behaves like a aluminium. Okay, okay. This gallium, which was not discovered at that time, so he just named it as a Eka aluminium. I just think that this element, it just behaves like a aluminium. That's why he just named it as Eka aluminium. Okay, and he gave some property, right? He just gave some properties also of this Eka aluminium and Eka silicon. Okay, so he just predicted. So atomic mass, he just predicted the atomic mass of Eka aluminium as 68. Okay, उन्होंने बस predict किया था. बट फर्दर जब ये एक्सपेरिमेंटली प्रूव हुआ, एक्सपेरिमेंटली ये भी फाउंड हुआ बाद में जब डिस्कवर हुआ गैलियम एंड जर्मेनियम, सो दे फाउंड दैट द prediction was correct, right? The prediction was correct because the properties which was predicted by Mendeleev's was found to be very much similar to that properties which was actual, right? जो actually में जो discover हुआ elements gallium and germanium, that's properties were very much similar to that which was predicted by Mendeleev. Okay, so you can see in the table. So this table, it shows different properties here. Like he just predicted atomic mass, density in gram per centimeter cube, is centimeter cube. Melting point in Kelvin, formula of oxide means when they form oxide, when they react with oxide, then what will be the general formula? Okay, formula for chloride. So they just predicted, he just predicted. So let's see, for Eka aluminium, he just predicted the atomic mass as 68. Okay, तो उन्होंने predict किया कि the atomic mass of Eka aluminium is 68. Okay, and the density is 5.9. Melting point is very low. Okay, he didn't give the exact melting point. He just said that the melting point of this Eka aluminum is quite low. Okay, and he just gave the formula of oxide. He said that when the Eka aluminum, when he gave the oxide, right, when he forms the oxide, so it will give a general formula of E2O3. Okay, and the formula for chloride he just predicted as ECl3. Like in the case of aluminium, aluminium क्या बनाता है क्लोरीन के साथ? Aluminium chloride, right? AlCl3. So this is the same formula, general formula, right? So that's why he just named it as a Eka aluminium, because it's these properties are very much similar to that of aluminium. So that's why he just gave it as a name Eka aluminium, and this germanium as a name Eka silicon. Okay, so germanium का उन्होंने क्या prediction किया? 72 as atomic mass. Okay, density he just assumed that is a 5.5 gram per centimeter cube. Okay, he predicted the melting point in Kelvin for Eka silicon as very high melting. General formula is EO2 and ECl. Okay, but but further, this was the predictions only. Okay, this was the predictions only. But further, when this Eka aluminum and Eka silicon, when it was discovered, right? When the gallium and germanium, it was discovered, right? So it was found that the properties, right? The various properties which were predicted by Mendeleev's, right? For these elements, gallium and germanium, right? They are found experimentally, right? When they are found experimentally, they are very much similar, right? They are almost similar to that which was predicted by Mendeleev. You can see the data. Okay, so he just predicted the atomic mass of Eka aluminum as 68, but gallium का जो discover हुआ, when the gallium was discovered, its atomic mass was 70. So it is quite similar. You can see 68 and 70. There is not uh, very much difference in these two, 68 and 70. So very much they are quite almost similar, right? Similarly, for Eka silicon, he just predicted 72, but the actual atomic mass was found to be 72.6. Okay. Similarly, you can see density 5.9, but density क्या आया? 5.9. Okay. Just like that. Melting point, he just predicted low, but melting point, it came to be 302.93 Kelvin. Okay. Similarly, you can see the formula E2O3. He just gave the general formula of oxide of Eka aluminum as E2O3. But in actual, the gallium exists as Ga2O3, which is very much similar to that formula, that general formula, right? So similarly, EO2, okay, GeO2. So you can see over here the predictions which was made by Mendeleev's was found to be very much correct. Right, predictions जो उन्होंने की थी, that was very much true, because the properties were which was found later was very much similar to that which was predicted by Mendeleev. Okay, समझ
Yes,
आए?
ma'am.
Everything is clear? Any doubt?
Ma'am. Ma'am.
Okay. So that was the Mendeleev's periodic table, which was very successful at that time, and he has many merits also. But yeah, still it has some demerits. Okay, I will discuss. Just let's discuss first, then I will give you time to write down the note. Okay. So first let's see the importance we have discussed, right? Because he just simplified and systemized the study of elements, okay, and their compounds. And Mendeleev, he corrected the atomic mass of certain elements with the help of their expected position and properties. And this helped to a great extent in the discovery of elements at a later stage. Yeah. And yeah, I have just discussed it. Eka aluminium and Eka silicon names were given for gallium and germanium. But at that time, gallium and germanium were not discovered. Okay. But later on, it was found that properties which was predicted by Mendeleev for those elements, gallium and germanium, were found to be correct, right? And those which were found experimentally were almost similar, right? So the predictions which was made by Mendeleev was correct. Okay. Now that was the merits. Yeah, that was the merit of Mendeleev's periodic table. And now see the demerit. What is the limitations or demerits in Mendeleev's periodic table? Right, क्या कमी रह गई? So let's discuss. So you can see over here the positions of hydrogen is uncertain. See the periodic table first. Yeah. So you can see over here the hydrogen have been placed in the group first, right? With alkali metals. These are the alkali metals. Right? Hydrogen, helium, these lithium, sodium, these are known as alkali metals. The first element. But hydrogen has been placed in first group according to Mendeleev's. But hydrogen also resembles like a halogen atoms. Now, what are halogens? You know very well: fluorine, chlorine, bromine, iodine, etc. These are known as halogen atoms, which is group 7 elements. Right? Group 7 elements, these are known as halogen atoms. So, hydrogen has been placed in the group first, right? By the Mendeleevs, but hydrogen also resembles just like a halogens, okay, which were placed in the group 7, okay, in many properties, right? बहुत सारी properties hydrogen की, it is just similar to that of halogen group, okay. But why, there's a question, why hydrogen has been put by Mendeleevs in the first group, why not in seventh group? ओके, वो तो सेवेंथ ग्रुप में भी प्लेस कर सकता था with these halogens, because hydrogen has many similar properties just like a halogen. Okay, so why just put it in the first group, why not in seventh group? Okay, so that's the controversy. Okay, so why the position of hydrogen is uncertain, right? Why he just put the hydrogen in first, why not in seventh? Right, so some scientists, उन्होंने ये कंट्रोवर्सी किया, राइट, उन्होंने ये क्वेश्चन रेज किया. So that's the major limitation of Mendeleev's periodic table. He just, because the hydrogen position is uncertain, was not fixed. Okay, was not fixed. So that was quite controversial. Got it?
Yes, ma'am.
Yes, ma'am.
Yeah, and yeah, also he doesn't separate the position of isotopes. Isotopes की separate position उन्होंने periodic table में नहीं दी थी. Right. What is isotope? Do you know what is isotope? Yes, what are isotopes?
The same atoms having different masses.
Yes, mass number is different, but atomic number is same. That's the isotopes. Okay. So we know that isotopes of an element have different atomic mass, right? Different atomic masses होते हैं. And this Mendeleev periodic table is based on atomic mass, not the atomic number, right? So isotopes of element have different atomic masses, right? But this periodic table has not give the separate position for the isotopes. Okay, this periodic table, they have been framed on the basis of increasing atomic masses of the elements, right? So the different positions must have been allotted to the all the isotopes, right? But Mendeleev ने ऐसा कुछ नहीं किया. Different position isotopes को मिलना चाहिए था, right? Because he just gave first, he just explained that I am just giving this periodic table based on the increasing atomic masses, right? And we know that isotopes have different atomic masses. So isotopes के भी different positions होने चाहिए periodic table में, right? Isotopes को भी different position allot करने चाहिए. But Mendeleev, he doesn't do the same. Okay, he doesn't did that. He doesn't give the separate positions to the isotopes. Okay, so that's the limitation. Clear?
Yes, ma'am. Clear.
Yes, ma'am.
And yeah, lanthanoids and actinoids, he just placed in two separate rows at the bottom of periodic table without assigning a proper reason. Okay, see, यहाँ पे तो आपको दिख रहा है यहाँ पे, right? But he just gave the periodic table and he just put this lanthanoids and actinoids just separately. He just उसे बिल्कुल separate कर दिया, right? He just placed it in a two separate rows at the bottom of the periodic table. Okay, and he doesn't explain the reason proper. He doesn't explain the proper reason. What was the reason behind that? Why just put the lanthanoids and actinoids in a separate rows. Okay, without assigning a proper reason, he just placed the lanthanoids and actinoids in a two separate rows. Okay, so that's the limitation. उन्होंने बताया नहीं था why he just put that. Okay, lanthanoids and actinoids, these are the F block elements. Okay, clear? So that's the demerits of Mendeleev's periodic table. I hope it is clear now. Yeah.
Yes,
Yes, ma'am.
yes, ma'am.
Okay, now. So I think we will start the modern periodic table in the next class, right? Because only 5 minutes are left, so you can just write down. You can now make notes from here. So this is the importance means your merits. You can write merits also. And can I scroll down
Yes, ma'am.
Yes, ma'am.
or draw this table? And
Yes.
they write down these merits.